Welcome to Skill 3. We are focused on regrouping and breaking apart fractions. These are the video notes for the first page of the Skill 3 notes. You need something to write with and crayons or colored pencils as we color in some models. All right, so to start out with Skill 3, we're really talking about how to take a mixed number and break it up into all of its pieces, and then how to take a broken apart fraction and put it together like a mixed number. So to do that, we need to start with some vocabulary. So let's start with this term right here, mixed number. A mixed number just means it's a number that has a whole number and it also has a fractional number. So here are some examples. Anytime you see the word examples, you'll know that it's showing you what a mixed number could look like. So here's my first one. This one is 2 and 1/3. This is a mixed number because it has the 2, which is your whole number, and it also has the 1/3, which is your fraction. So 2 and 1/3 means that I have two whole numbers and then 1/3 left over. So I have enough to fill two whole pieces, two whole numbers, and then there's a third left over. Let's look at another example. Here I have 13 and 7/8. Let's draw an arrow to the whole number, which is 13, and then another arrow to the fraction, 7/8. It's a mixed number because it's made out of that whole number and then the leftover pieces. This last one looks kind of wild because it's so big, but it's still a mixed number. It's 516 and 27/100. It's made up of a whole number, 516. So I could think of that like 516 whole things, 516 pizzas, 516 brownies, 516 unopened containers of juice. And then I have this fraction over here, 27/100. Now that's a really big numbered fraction, but it's still a fraction. So all three of these examples show whole numbers and fractions together. So they're examples of mixed numbers. I'm going to switch my color. You don't have to, but I'm going to switch my color now for a minute to look at some non-examples. Non-examples means these are not mixed numbers. They're showing you things that might try to trick you, but they're not really mixed numbers. In fact, I'm going to draw an X right here to remind us that these are not mixed numbers. This first one here is the number 7. Now, 7 is a whole number, but it doesn't have a fraction with it. It'd be like 7 whole pizzas. It's not a mixed number because it's only got a whole number. This next example, 12 and 25/100, sounds like a fraction when I say it out loud, but when I see how it's written, they didn't write it like a mixed number. It does have a whole number here, that's the 12, but this part in the back is what makes it not a mixed number. The part in the back is a decimal. Now, some of you very smart people might say, wait a second, I could write 12 and 25/100 like a mixed number. I'm going to do that over here. I could write 12 and 25/100. If I wrote it this way, it would be a mixed number. Check mark, yes. But over here, the way this one is written, it's not written like a mixed number. It's written like a decimal, so it's not a mixed number right now. If they rewrote it this way, it would be, but the way it's written right now, it's not a mixed number. Oops, I should have put an X over this one since it is only a whole number. And then this last one here is 3/5. 3/5 is a fraction, but I can't call this a mixed number because it's missing the whole number. So it's only a fraction. So this is what we're going to mean when we talk about mixed numbers. A mixed number has a whole number and a fraction. We're going to be using this term a lot, so I'm glad that we had the opportunity to really define what we mean. Moving on, let's talk about how you can build a mixed number. Right here in our draw it says to turn an improper fraction into a mixed number. Now, we haven't talked about improper fractions yet. That'll be on page 2 of these notes. So don't stress if you don't yet know what an improper fraction is. Right now, all I need you to think about is if I have a lot of fractional pieces, how could I figure out if it should be written as a mixed number? These notes use the word turn, but sometimes they'll use the word rewrite. So you can say to turn an improper fraction into a mixed number, or sometimes they'll say rewrite the improper fraction as a mixed number. It means the same thing. So let's take a look here at this fraction. We have 5/3. That means there are 5 pieces and they're all cut into the size 1/3. So to show that, I'm using our pattern blocks examples, and they have those blue rhombuses since they're each worth 1/3. I'm going to write 1/3 in each of them just to help me really remember what they're worth. And now I want to come up here and I'm going to use my blue. I'm going to color them in so they really look like those blue pattern blocks we use in group. Use your crayon to do the same. Hopefully you can do a neater job than I do on the computer. All right. So the big idea that I'm working with here is that if I'm working with pieces that are the size 1/3, I know that I can group 3 of them together to make one whole. So as I look at these pieces, I want to circle a group of 3. Those 3 pieces would be like 3/3. I know that 3 of them will make a whole number because 3 is my denominator. If I do that, I still have these left over. There's 2 of them, so these would be 2/3. In the next set of pieces, what they did is they took these 3/3 and did what you like to do with them in group. They pushed them together to make a whole number. So here's those 3 1/3 pieces all pushed together, and you can see they have the same shape as the one whole, the yellow hexagon. And then these leftover pieces, these are just right here. They pushed them together, but you can see there aren't enough to make a whole number. So here's a 1/3, and here's a 1/3. Let's go ahead and color those ones in. Here's those 3 1/3 pieces pushed together, and here's the 2 leftover 1/3 pieces. Finally, in this next step here, actually before we do that, let me show this. These 3 1/3 pieces are still 3/3, but now I'm going to box them to show they're all pushed together to make one whole. And I'm going to add them with the 2/3 that we have left over. Here's my 3/3, and now that I pushed them together, I'm going to box them to show it's a whole number. And then I'm adding those 2/3 left over. So now looking at the final step, these 3 1/3 that are all pushed together and boxed, they're going to swap them out for what they're equivalent to. They're worth one whole, so they swapped them out for a 1. And then my thirds that are left over, they didn't get swapped because they didn't make a whole number. So I still have 1/3 and 1/3. So now I have 1. I traded my 3/3 for a 1. And I'm adding the leftover 2/3 to it. And then I'm going to color those in to match that thinking. So instead of having the blue 3/3 together, this got swapped out, I should say, for a 1 whole, one of those yellow hexagons. And my 1/3 are still 1/3 pieces. Finally, I can take this 1 and 2/3 and get rid of the plus sign. I'm going to write it like a mixed number. I'm going to write it like 1 and 2/3. All I did is get rid of the plus sign and smoosh the whole number and the fraction together. Now instead of it being written like an addition equation, I can write it like a mixed number. The big idea that we're working with through all of this is this thinking bubble here. Whenever I need to build a mixed number, I want to think, how many whole numbers can I make? I'm looking at the total number of pieces and I'm grouping them into sets that make a whole number. Now, sometimes it really helps to draw it or build it with pattern blocks. I love to do that because it makes it so clear. But that's a lot of work every single time. You're not going to want to have to draw it out or get the pattern blocks every time, especially once you really start to understand this concept. So as this makes more sense to you, as you're starting to see the pattern, you're going to want a way to do it just with numbers. So let me show you a solve it strategy. Once you understand what we're doing, this is a way to do it more quickly on paper. So I'm going to start with a different fraction, one that's kind of hard to show with pattern blocks. This is the fraction 12/5. What I'm going to do with it is think about the fact that I have pieces that are worth 1/5, and I have 12 of them. And I'm going to start breaking them up into groups that are equal to one whole. To do that, since I'm working with fifths, I can make groups of 5/5. So I could make one group of 5/5. And if I started with 12 and I made one group of 5/5, if I take away those 5/5 that got used right here, I have 7 pieces left. Looking at that 7, I know I have enough to make another group of 5/5. So that's what they did here. Here's another group of 5/5. So I'll take away the 5 used there. So let me make sure that looks like a 7. And we have 2 left. If I only have 2 pieces, I recognize there's not enough to make yet another group of 5/5. That will become my leftover 2/5 fraction, just like up above when I had a leftover 2/3. So looking at this, if you wanted to draw it, you could think of it like I'm going to draw 12 pieces. And I want to make groups of 5/5. So I could group these 5. And that's a group of 5/5. I could group these 5, and that's a group of 5/5. And then here are my 2 left over. Those are my 2/5. If drawing it helps you in these early stages, you're welcome to do that. All right, so we broke it all apart into groups of 5/5 and 5/5, and then we have 2/5 left over. I know that this 5/5 is worth one whole, and this 5/5 is worth one whole, and then we have those 2/5 left over. The next step is to put together all the whole numbers, and they did that right here. 1 plus 1, they rewrote as 2. My 2/5 can't get regrouped, it just is 2/5. And then the final step is we don't need a plus sign anymore. We can just smush them together and write it like a whole number, 2 and 2/5. So whether it helps you to draw it out to show your thinking, to rewrite it with group fractions like this, or to draw dots, be thinking about which way helps you best understand the concept and helps you show your thinking. Ultimately, our goal is to work toward being able to write it out mathematically because this is more efficient. Now let's move on to the try it. You have a choice here when we get to the try it section. You could choose to work independently by pausing the video, solving the problems, and then checking your work against mine. If you don't feel ready for that yet, just work along with me. And if you start to feel more confident, you could pause the video at any time and then go back and restart it when you're ready. Here we go. I'm going to start here with 7/3. If I have 7/3, I can write that out over here, 7/3. In order to make whole numbers, I want to pull out groups of thirds that are equal to one whole. And thinking about that, if I'm working with thirds, I know 3/3 makes a whole number. So if I pull out a group of 3/3, and I started with 7, actually I'm going to write it on the other side. I started with a group of 7, take away 3, I have 4/3 left. That tells me there's enough to make another group of 3/3, so I'm going to do that. Plus 3/3 again. Now, if I take away those 3, I'm left with 1. That's not enough to make another group of 3/3. So that's going to be my leftover fraction. 1 piece, and it's still cut into thirds. All right, so I took my 7/3 and I rewrote it as 3/3 plus 3/3 plus 1/3. At this point, I sometimes like to check my work by adding those numerators to make sure they all equal back up to my starting number. 1 plus 3 is 4. 4 plus 3 is 7. Perfect. I used all my thirds. Now I'm going to think about these like the whole number they represent. So 3/3 is worth 1, plus 3 more thirds is worth 1, plus I have that 1/3 left over. Now I can combine my whole numbers. 1 plus 1 is 2, and I'm adding 1/3. And now I'm going to rewrite this like a mixed number, 2 and 1/3. So 7/3 is equal to 2 and 1/3. Let's try another one. Here I have 17/5. So I'm going to write 17/5. And since I'm working with fifths, I need to make groups of 5/5 for my whole numbers. If I started with 17 and I took away 5, 7 minus 5 is 2, 1. I have 12 left over. That's definitely enough to make another group of 5/5. Take away those 5. We got to do some borrowing. 0. 12 minus 5 is 7. If I have 7/5 left over, I have enough to make another group of 5/5. 5/5. 7 minus 5 is 2. If I only have 2 left, I don't have another group. I don't have enough to make another group of 5/5. So that's just going to be 2/5. Notice anytime I have the same number on top as I have on bottom, I'm boxing it to remind myself that's worth 1. I didn't box 2/5 because it's not a whole number. It's only 2 out of those 5 pieces. And then I'm going to count it up just to make sure I have all the pieces used. 5, 10, 15, plus 2 more is 17. Perfect, that's what I started with. Now I'm going to think about how these 5/5 are a whole number. 5/5 is worth 1. These 5/5 are worth 1. These 5/5 are worth 1. And then I have those 2/5. Combine my whole numbers. 1 plus 1 plus 1 is 3, plus 2 more fifths. And then I'll get rid of the plus sign and rewrite it like a mixed number. 3 and 2/5. So 17/5 is equal to the mixed number 3 and 2/5. All right, one more problem to go. If you're feeling confident, try pausing and doing it on your own and checking your work. If it still doesn't make sense, work along with me. Here we go. 16/4. And since I'm working with fourths, I need to make groups of 4/4. 4. This time I'm going to try counting up. 4 plus 4 more is 8/4. Plus 4 more. Let's see here. 4, 8, 12. Ooh, I'm going to keep going. 4, 8, 12, 16/4. I used up all my fourths and I don't have any left over because 4 plus 4 plus 4 plus 4 is 16. All right, since I used them all up, I can start rewriting them as ones. And now I can add up all my ones and I get 4. There is no fractional piece to this. So for 16/4, I'm not going to write it as a mixed number. I get to rewrite this one just as a whole number. So this is the strategy for taking many fractional pieces and rewriting them either as a mixed number or, as we saw in our last problem, as a whole number. Double check to make sure you have these notes finished, and when you're ready,